Hey guys, in this video we're gonna be doing some time problems mainly, which means that we're gonna be solving for time in one-dimensional kinematics. So let's start with this pretty simple example. We have this following statement. Tom travels at 5 meters per second. He's going pretty fast. And he's trying to get home from school, which is 2.2 kilometers away. How long will it take Tom to get home if he's traveling at that speed and he needs to move this distance? So first of all, this is a pretty simple problem. So first of all, we know that the units that we have are not the same, so we need to change them. I'm going to move kilometers to meters in this case. So we have 2.2 kilometers is the same as if we had 2.2 groups of 1,000 meters. Remember, a kilometer is 1,000 meters, and in this case you have 2.2 groups of 1,000 meters. So this is times 1,000 meters. Now this would be equal to the 0.2. You can just take it as adding 0.2 of 1,000 to 1,000 meters, so you would have 2,200 meters. Now we have these units that we have meters that matches the velocity that we have. Remember, in this case we have a velocity because we're being given a direction. Tom is traveling in a direction and we know it, so it's a velocity. So we have that velocity is equal to, just so you guys remember the equation, displacement divided by the change in time, or just simply time. So we have velocity, we know how much that is, and this is equal to displacement, which is 2,200 meters, and all of this is divided by time, which is what we need to find. Now let's solve for time. In here we would get that this is time times and this is equal to 2,200 meters. Now we need to move this one to divide to the other side, or just divide by 5 meters per second on both sides, and we would get that time is equal to 2,200 meters divided this. Now here we have a fraction dividing another number, and what we can do in this case is just simply multiply by the inverse. Okay, if you do not remember that rule, is this one. A divided V over C, you could say, is the same as if you had A times the inverse of V over C, which is C over V. Okay, so now if we apply this rule up here, we would get that this is going to be equal to 2,200 meters times 1 second, and all of this divided by 5 meters. Now meters cancels out meters on top, and you would get 2,200 divided 5 times seconds. Okay, and now this division we would have, if it was 2,000, that would be like 20, so 400, and 200, that's 40, so 440. It's this division, 440 times seconds. We have 440 seconds, so this is the answer we're looking for. Now, how do we prove that is the right answer? Or how do we know that, in fact, Tom will take 440 seconds to travel 2,200 meters, moving at 5 meters per second? Well, we can prove it with this equation. So I'm gonna do that down here. So we should get that we know the velocity is 5 meters per second. So if we divide our displacement, 2,200 meters, by 440 seconds, we should get 5 meters per second, I'm sorry. So we should get that velocity should be equal to 2,200 meters divided by 440 seconds. So we can just play with the coefficients of the units. So we would have 2200, that's a 0, divided by 440 times meters per second. Remember, this is a good practice to take out the units outside the expression that you have. And in this case, we can cancel out this and this. 220 divided 44, let's take halves. So we would have 110, 22, 11, and 55. So 55, and it's actually 5, yeah. 55 divided 11 times meters per second. This is the same as 5 meters. Let me write it a bit, maybe cleaner. 5 meters per second. So indeed, 5 meters per second is a velocity that is corresponding to these two values, which means that 440 seconds is indeed the answer that we're looking for that problem. Now, what if we wanted to take these 5 meters per second and turn it into kilometers per hour? Let's see how we could do that. It's just playing with the units. So I'm going to erase this. Remember, the answer that we got was 440 seconds. So let's do it. 5 meters per second. I'm going to write 1 second so you guys have a clearer idea of what we're doing. So now in terms of a kilometer, we know 5 meters would be 5 divided 1,000, which is just 5 meters inside 1,000 meters. So we have 5 divided 1,000 meters. And now in this case now, of course, yeah, you gotta be careful because I'm gonna write it again. In this case, you would have that 5 over 1,000 kilometers. Okay, 5 meters is equal to this amount of kilometers. And all of this is being divided by same thing. So if we have 1 second inside an hour, which is the unit we're trying to get to, well, we would have this is 1 divided. And now how many seconds do we have? Well, we know it is 60 minutes, and 60 minutes is equal to 1 hour, and each minute has 60 seconds, 3,600 seconds. And now this is not gonna be seconds, but rather hours. Okay, this is what 1 second is, and this is what 5 meters is. And now if you remember the previous rule, you know that we can multiply by the inverse of this fraction, this one on top. So in this case, we would get that this is 5 divided 1,000 times 3,600 over 1. And of course, you've got the units here. So in this case, you would be taking here kilometers. And down here, you would be taking hours over 1 hour. And now let's make this multiplication. So yeah, let me do it real quick up here. So we have 36 and 5. This is 30, 15, 18. So we get 180. And now the zeros, that's 18,000, I believe so. Yeah. And all of this divided by 1,000 hours. And on top we get kilometers. Now remembering here, we're just multiplying by 10 a couple times, so we can take away these zeros. Okay, we're just multiplying by 10 3 times, and we would get that this is equal to 18 kilometers per hour. So 5 meters per second is equal to 18 kilometers per hour. Now let's do a more complicated problem. So we're gonna have in a marathon, team runs at 20 meters per second and hits the 100-meter mark 5 seconds after he starts running. After starting the race, how long will it take him to reach the 500 meters mark? So in this case, we're also gonna be using our kinematic equations, well, the most basic one for now, but we're going to be playing with the change in time, okay? So let me show you. So we know velocity is equal to the displacement divided by the change in time, okay? Now, we've been treating the change in time just simply as t, just a value for time. But another way in which you can say delta t equals, or something delta t equals to, is the final time minus the initial time, okay? Now, what are these two things? You could say that if you have some sort of displacement, there is a very strong relationship between displacement and initial and final times. If you have a displacement from point A to point V, and this, let's say this displacement was this way, and this happened between, let's say, 0 seconds, the beginning of this period, and 10 seconds, the change in time would simply be the subtraction between 10 seconds minus 0 seconds, which is why we've been always treating change in t as t, okay? Just assuming that whatever we're dealing with is starting at 0 seconds, okay? So, as you can see, this is just simply like taking from a huge line of time, because before 0 seconds, well, you also have time, okay? Not negative time, but before 0 seconds, something else was happening. But basically what you're doing here is just grabbing this net period of time, okay? And that is what you do with this abstraction. So, how do we solve this problem? And why do we need to use this? Well, we know initially that his speed is 20 meters per second. This goes in black. So we know his speed is 20 meters per second. And in this case, displacement, what we're gonna do is, we know he hits 100 meters in 5 seconds, right? Which is accurate to his speed. And what we need to do to find displacement with that information is that we're going to see how much he's moving in between the 100-meter mark and the 500-meter mark, okay? And in this case, we will also define the change in position, okay? And the change in position is implicitly displacement, okay? You could write here delta to say the change in displacement, but that's not the right notation or the right way of applying intuition to it, okay? Because displacement already implies a change in position. So we're just gonna leave it like S is gonna be equal to, or displacement or our change in position will be 500 meters, which would be the last position, minus the initial position that we know that Tim got to, or that he reached. So we would have 500 meters minus 100 meters. And all of this will be divided by the change in time. Now, we need to know the final time, because we are being asked after starting the race, which is before our initial time, you could say, because our initial time is 5 seconds, because that is when he will be, that is when he starts moving this from 100 meters to 500 meters, and then when he's done, you could say, yeah, when he's done moving these 400 meters, that's what we're going to say TF, time, final time. And this final time would be the final time of the entire marathon, or of the entire, not the entire marathon, but the entire thing that we're seeing, or the entire picture. So in this case, TI would be 5 seconds. So we have TF, what we need to know, minus 5 seconds. And now we need to solve for TF. So in this case, we need to move the entire denominator to multiply. So we would have TF minus 5 seconds multiplied. And this is equal to 400 meters. Cool. Now we need to find TF, so I'm going to divide by 20 meters per second on both sides, and then add 5 seconds. So we're gonna have that TF is equal to 400 meters divided 20 meters per second plus 5 seconds. And now let's separate this. So we have final time would be equal to, we know this is the same as multiplying by the inverse of this fraction. So we would have these zeros, they would cancel out first of all, and you would get 20 meters. I'm sorry, meters cancels out with meters too. So you would get 40 seconds plus 5 seconds, okay? These meters, they went out. And in this case, you can see that the final time is equal to 25 seconds. Now, is this measurement right? Well, let's see that. We know that if he's traveling at 20 meters per second, it should be congruent that he reaches 500 meters of displacement in 25 seconds, which means that we should get that. Let's see what choice do we get? Let's find speed, for example. So let's say that in this case, not speed, velocity, I'm sorry. So our velocity would be or should be equal to, if this number is right, to 500 meters divided by our answer, seconds. And this is gonna be equal to, indeed, we should get 2, that would be like getting 250 divided by 25, or just simply 20. So we get 20 meters divided seconds. And this is our answer, which apparently is the same speed, speed in this case, speed of Tim, which means that this value in here is indeed correct. So this should be all the problems that we do today. So I hope you guys enjoyed this video, and see you in the next one.